So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. These are the two options. So you can use either of the option. Okay, which is the correct option you will take? I don't remember what you had written. Two answers yesterday. Anyway, let me repeat. So this is the functional group fluorine. So the functional group gets a preference. So this is one fluoro. One fluoro. Okay. 7 carbons. It is heptene. And then numbering 1, 2, 3. So it will be 5 phenyl, 6 dimethyl, right? So it is 5 phenyl. No, it is 6 dimethyl, 6 dimethyl, 5 phenyl, heptene. Okay, now remember the order is like this. The name should be given in the alphabetic order. So F is the first one, fluoro F. Then here di is not considered. Mono, di, tri, tetra, these are not considered for alphabet. So M is the alphabet here. And P is the alphabet. So the alphabetic order is F. After the F comes M. After M comes P. P. So we say fluoro first, dimethyl second, and phenyl third. So this is 1 fluoro, 6 dimethyl, 5 phenyl heptane. Okay, so this is the naming of the. What about the names of alcohols? Alcohols. Alcohols. Yeah, I'll give. What is the structure of butane 2-ol? But 3 2-ol. Yeah, so it is butene 2-ol. But means 4 carbon, 2, 3, 4. 2-ol. 2OH. 3 in. 1, 2, 3 in. So numbering is 1, 2, 3, 4. Okay. So this is. And then what is the name of this compound? What is the name of this compound? Let's draw the names of a few more compounds. I'll give you. Draw the structure of 3-methyl but 2-enol. Okay, just wait for a few minutes. I will take a different textbook. Okay, 1 sec. Let me take out a little more problems and see. One sec. Let me see. Yes. Okay. Now this one, this is an ether. Okay. Ethers are named as oxy compounds. Oxy. Now you identify the two sides, this group and this group you identify. This is methyl. This is, what is this? This is what? 1, 2, 3 propane. 1, 2, 3 propyl, right? Methyl propyl. 2-methyl propyl. 2-methyl propyl. So one side we have methyl and the other side 2-methyl propyl. Okay. Now what you do? The smallest one, you mix the oxy with the smallest one. So it is methoxy. Methoxy 2-methyl propane. Methoxy 2-methyl propane. Okay. Now what about this compound? 3-methyl but 2-enol. So it is but 2-enol. Ol means aldehyde. CHO. Remember, CHO comes only at the one end of the molecule. CHO comes only at one end of the molecule. So this is ol. Now butenol, but means 4 carbons. So 1 carbon is already here. Now you have 3 more carbons. Okay. Now on 2 you have a double bond. So this is 1, this is 2. So you have a double bond between 2 and 3. Now 3-methyl. 1, 2, 3. There is a methyl. Now let us put the remaining hydrogens. Here it is CH3. Here no more hydrogen required. Here there will be one bond here and one hydrogen here. This is the compound. Okay. Now draw the structure of cyclohexane 3 in 1 ol. Cyclohex 3 in 1 ol. Try that. Everyone can try. All of you can try it. Cyclohex 3 in 1 ol. So it is cyclohexane molecule. This is cyclohexane. Okay, 1 ol. So put the 1 ol there. So this is one carbon number 1. 2. This is 3. From 3 there is a double bond. See here. That's all. Right? What is the name of this compound? What is the name of this compound? Give the name of this compound. Yeah. So 1, 2, 3, 4, 5, 6. So 6 carbons. Hexa. Okay. Alcohol. Ol. How many alcohol? 2 alcohol. So diol. What are the ols? 1, 2, sorry. 1, 2, 3, 4, 5, and 6. So it is 1,4 diol. Then next one, 5-methyl. See that 5-methyl hexa 1,4 diol. Right. Next, look at this one. CH. What about this one? And of course, this also. You can try in the same way. Okay, now try. Uh, so functional group is OH, so it is old. Now where is the old? Now number 1, 2, so it is 2 old, 3, 4. Okay, so it is 4 carbons. So butane, BUTAN, butane 2 old. On second carbon, you have a methyl group, so 2 methyl, so 2 methyl, and 4 have a phenyl group, 4 phenyl, 2 methyl, 4 phenyl, phenyl butane 2 old. Now the second one, simple one. Yeah, again it is an ether. Functional group is ether. So ether is you either side of the oxygen atom you identify the group. So this is methyl. On this side you have benzene, and here also you have benzene on one side and methyl on the other side. So the smallest one, only one carbon is here. So we call it as methoxy. This is methoxy. Okay. How many methoxy? 2 methoxy groups. So we will call it as dimethoxy. And remember, where are methoxy groups? If you number this as 1, this is 4. So 1, 4 dimethoxy benzene. 1, 4 dimethoxy benzene. Okay, so this is how the nomenclature we have. When we talk about each functional group, we'll discuss more this is naming. Let's come to briefly about isomerism. Isomerism. Yeah, tell me one by one. Chain isomerism. Number 2, position. Number 3, functional group. And number 4, metamerism. Metamerism. Okay. Chain isomerism. Difference in chain 1, 2, 3, 4, 5. And 1, 2, 3, 4. See, this is chain isomerism. Position isomerism 1, 2, 3, 4, 5. Cl 1, 2, 3, 4, 5. Cl. That's all. Okay. Position of the functional group is different. Functional group isomerism, here is OH and here is, just check, molecular formula is same. This is alcohol, this is ether. Same, different functional group, same molecular formula. I think it should be the same. Right? Okay. Metamerism 1, 2, 3, 4, 5, 6. Then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yes. See here. The position of the functional group inside the chain is different. Okay. . So the different number of alkyl groups on either side. Similarly, you can have NH also, same way. 1, 2, 3, 1, 2, 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So this is metamerism. So these are the four types of isomerism, which is difference in structure. So we call this as structural isomerism. Then we have stereoisomerism. Stereoisomerism. There are two types. One is cis trans. Cis and trans or geometric isomerism. Geometric, cis trans or EZ. All the three are same. Two types of compounds will show. One, double bonded compounds, and two, ring compounds. Double bonded compounds, example, this is the example. Groups on different sides of the double bond. And ring compounds, this is cis, this is trans. Okay, so that is geometric isomerism. Let's look at the next one is optical isomerism. Optical, meaning that we have discussed in detail in one whole chapter. Say for example, we can draw two optical isomers, compound containing different atoms and groups on the same carbon. Cl, COOH, H, and OH. Now the mirror image of this COOH, Cl, OH, and H. These two are non-superimposable mirror images, and they are optical isomers, which you call as enantiomers. Okay, we'll come to that in a separate chapter. Now let's look at the structure and bonding. Structure and bonding. Okay, now how do you form a methane molecule? Methane molecule. How is a methane molecule formed? First of all, carbon. We'll draw the ground state configuration of carbon. Ground state configuration of carbon. 1s2, 2s2. I have to put 2 electrons here. 2s2. Then here is 1, 2, 3. 2p. How many electrons left? 2 plus 2 plus, yeah, 2 more electrons. One I'll put here, one I'll put here. This is 2. Now, excited state configuration. Oh, 10 more minutes. Excited state configuration. What happens is this electron goes over here. So it becomes 2s1. Yes. 2p3. Okay. Now what is the next step? Hybridize the state. What's the hybridized state? These will mix up. They will mix up. So 1s2 remains the same. 1s2. Now they will form 4 orbitals. 4 degenerate orbitals. So sp3 orbitals. Now it is not neither s nor p, it is sp3 hybrid orbitals. And see here, this process is also a sort of lowering of energy. sp3 orbitals will have lower energy than this. See, for example, one s orbital and 3p orbitals. One s orbital and 3p orbitals. Okay. They will hybridize to form. So there are 4 orbitals, 4 molecular orbitals. 4 molecular orbitals, 2 will be bonding and 2 will be anti-bonding. Okay, you don't have to worry about that, those part. Person. Now, once you have formed the hybridized orbitals, each of these orbitals will, now these 4 hybridized orbitals will be pointing in 4 different directions in a tetrahedral fashion. Okay. And then, and this orbital will be pointing towards you. This orbital is pointing towards you. And there is one orbital behind this. Exactly behind. Okay. Exactly behind this. Now see, this is what we are representing. This orbital is represented by a wedge. And the orbital behind it is represented by a dotted line. And the orbital on the top and on this side. So the bond angle is 109 degrees. Bond angle 109 degrees, 28 minutes. And now one hydrogen each will bond here, here, and here. So let me put the hydrogen here, 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 and here. Okay. So this is an sp3s bond. sp3s bond. S bond of hydrogen, sp3 bond of carbon. This also is sp3s. All of them are sp3s bonds. Okay. Next. Yeah. I clear the board. If we have written, if somebody is writing it. sp2 hybridization. Okay. sp2 hybridization, we can generate an example is ethylene. ethene, CH2, double bond CH2. We can write in the same fashion. Ground state. 1, 2, 1, 2, 1, 2. Excited state. 1, 2. This is 1. Same thing as we have done in the case of methane. Excited state. Then we have hybridized state. Now you have a difference. 1, 2, 1, 2, 3, and 1. 1, 2, 3, and 1. See that? What's the difference? This is sp2. 1 s orbital and 2 p orbitals. You can choose any of the p orbitals, px, py, or pj. And one of them remains unhybridized. Now these three will orient in this space in equal direction. These three are hybridized, so they will orient in equal direction. 1, 2. See, equally oriented, and all the three will be in a single plane. So you have one carbon here. Now you have a similar carbon on the other side. So a very similar carbon on the other side. Okay. So these two carbons will form a bond. And then you have two forming a bond here, one H here, one H here. So this is a sp2s bond. This also is sp2s bond. And here also H, yes, see here. Now let me rotate this in this plane, 90 degree. See here, it will almost look like this. One bond, see straight. And second bond is below this. Okay, you cannot see it. I'll just draw the outline below, like this. Okay, and here these two. See here. And then on the other side also you have the same picture. Then see here on the background. You have the next object. Okay. So this is how it looks like. Now we have the one unhybridized p orbital we are not accommodated. That we have to put here. So that unhybridized p orbital, if you look at this structure, one lobe will be pointing towards me. Suppose this is the unhybridized p orbital. I'm fitting it here. This side is pointing towards me, and the other side is pointing away from me. It will be, if I observe it, it will be like this, perpendicular to this plane. Now when you rotate it, here it will appear like this. Here it will appear like this. And now they will form a bond here. They will bond